Okay, here we go. So now what we're going to do is we're actually going to go on to two-step stoichiometry. It's a little bit longer than what we did in the past, where we only had to do one math problem. Now we're going to have to do two math problems in order to figure this out. So what I want you to do is go ahead and take out this paper, and you can go ahead and pause me right now to go and find it. And I'll be here sitting and waiting. While I do that, I'm going to just set up my marker. Alright, so hopefully you should have your map out now. A couple things we should do is draw a line down the center of it to kind of split up both sides. Okay? There's a couple other things that I want you to write on it, and it's some arrows. Okay, you see how we have this arrow going from mass to mole? Go ahead and draw an arrow right on your mole map like that. And by it, I want you to put 1 mole over grams. Okay? That means that when I try to convert from this mass to this mole, I will always have 1 mole on top over some number of grams. Okay? It's just the trick that we're always going to use. When I go from volume to mole, say I'm going this way, what we're going to do is we're going to have 1 mole over 22.4 liters. And that's what this number right here is just trying to show you, this 22.4. Okay? Then lastly, let's say I'm going from particles to moles. So up this way. I'll go ahead and draw this down here. Let's say that I'm going to have 1 mole over, oops, I'm sorry, let's see, how do I get back there? There we go. 1 mole over 6.02 times 10 to the 23rd. Okay? So that's the 3 first conversions that we're going to do. Maybe if we go from mass to mole or volume to mole or particle to mole. Okay? If I want to go from mole to mole, like we've done in the past with the one-steppers, what we're going to do is we're going to, hold on, let me erase this little bit there and go back. Pen, ink color. Okay. What we do is, remember, we put moles wanted all over moles given, right? That's what we were doing in the past when we were doing the one-step problems. Okay, so now let's say that I'm at moles given. Okay, and I wanted to go to a mass. Well, I'm going to go up this time. Okay, and it's actually going to be the opposite of this one over here. So instead of 1 mole over grams, it's going to be grams over 1 mole. Okay? Let's say that I'm going from mole to volume. This time it's going to be 22.4 liters over 1 mole. Okay? Then lastly, down here, I'm going down this way towards particles, it's going to be it's going to be actually 6.02 times 10 to the 23rd over 1 mole. Okay? I know it's a little sloppy on here, again, because I'm writing with that, I'm writing with my mouse and not with an actual pen, but I think you should be able to read it still. But I want you to make sure that you have these written on there with the arrows, because believe me, it'll make drawing those lines so much easier for yourself. Okay? Alright, let's go ahead and go on to the next slide. So, what I'm trying to basically tell you here is that when we go on longer trips on that chart, I'm going to need some more information. Just like you would bring a lot of luggage on a longer trip, if you're going to maybe like California instead of Detroit, you would bring a lot more luggage to go to California. Okay? So some more information that we might include are going to be finding molar mass. Okay? How much does that element or that compound weigh? Using 22.4 liters, or using that 6.02 times 10 to the 23rd. Okay, so that's a couple more things we're going to need to know. All right, we talked about this in the past. What is this molar mass thing? Okay, in case you forgot, molar mass is the mass in grams of 1 mole of an element. So its unit we're going to use, remember you always got to have units, is grams over moles. And here's my buddy lithium right here. See, he's my buddy. He's smiling at me. Okay. Lithium weighs on the periodic table 6.941 grams. Okay. I have oxygen. If we looked at oxygen, oxygen on the periodic table would be 16. And if we had chlorine, if you took a look at your chlorine on your periodic table, that's 35.45. Okay, it's those little numbers in the bottom of the periodic table. Okay. All right. So let's just look at a few more examples here. Now you guys can write these down in your notes. I'm just going to help you out. If we looked at hydrogen, okay, I'm looking at hydrogen. It's 1.01 grams per mole on the periodic table. If we had carbon, okay, carbon, that's 12.01 grams per mole on the periodic table. But let's say that I had CH4. CH4 isn't on the periodic table, but its components are. So I know that I have 1 carbon and I have 4 hydrogens, right? Well, 1 carbon is 12.01, right? And each hydrogen is 1.01. Well, that means that it's going to, when I add these up, or excuse me, I'm ahead of myself here. I'm going to take 4 times 1.1, and I'm going to get 4.04. Sorry, I apologize about that. So you got 4.04, and now we're going to add these two numbers up. Okay, so now when I add 12.01 and 4.04, you're going to get 16.05, right? Grams per mole. We can actually check our answers. You can sort of see it under there if we erase our ink. 16.05, just like we added up. Okay? All right, take a second, write down this example, leave some space in between these. All right? Leave some space in between those, and then we'll be able to solve this problem. Okay, so hopefully you wrote down those two things. So it says, given 12.3 grams of KClO3, how many moles of O2 would I have? Okay, so we're looking to find O2. And I have 12.3 grams of KClO3. Okay, we can do this. This is simple. So we have 12.3 grams of KClO3. Okay? All right, let me just run back really quick here. And just again, we'll look at that map really quick right here. Okay? So I'm starting at grams, our mass. I'm going to go from mass to mole, and then from mole to mole. So notice 2 steps. 1 step, 2 steps. Okay? And this is where we're going to use this 1 mole over grams thing that I made you write down. Okay? That's why that was very important to write down. Okay? So I know that I'm going to put 1 mole of KClO3 on the top. Okay, on the bottom, I'm going to put grams of KClO3. Okay? Well, we have to figure out how much KClO3 weighs. Well, it has 1 K, it has 1 Cl, and it has 3 oxygens, right? Well, each oxygen weighs 16, each chlorine weighs 35.45, and each potassium weighs 39.10. Okay? So that means that I have 39.10 times 1, which is 39.90, or 39.10. I have 1 times 35.45, again, the same number. And then I have 3 times 16, and that's actually going to be 48. So I'm going to take 48 plus 35.45 plus 39.10. Let's just quickly make sure we know what that is. It's 122.55. Okay. So I have 122.55 there, but that's only the first step. I need 2 steps, right? So now I have to do another block, because now I have to go from moles of KClO3 to moles of O2. So like what we did in the past. Okay, so since I want O2, that means I'm going to put 3 on the top. Since I started with KClO3, that means I'm going to put 2 moles of KClO3 on the bottom, just like that, okay? Now, everything is set up. 1 step, 2 step, okay? All right, so now we take 12.3 times 1 times 3 divided by 122.55, divided again by 2. In your calculator, you should get 15055. But since we started with 1, 2, 3 sig figs, I have to have 1, 2, 3 sig figs. This 5 is going to round the 0 up. So my answer should be 0.151 moles of O2. Okay? That's the first 2-step problem. I know it's pretty long, but trust me, it'll get way, way easier. Okay? So let's go ahead and we're going to try the second one. Okay, so given 4.53 moles of KCl, how many grams of KClO3? Okay, so I know that I have 4.53 moles KCl. We're going to set it up. I have 2 KCl's. I have 2 KClO3s. Well, since I want KClO3, I'm going to put 2 moles of that on the top. I put 2 moles of KCl on the bottom. Now I have to go from moles to mass, or to grams. And if I fly back to this original table here, somewhere, oh, I guess it erased. Oh no, that's tragic. What it should have been grams over 1 mole here. So that's what we're going to do. Okay, so we're going to go back to that slide. So I'm going to put grams over 1 mole. And oh, lucky us, we already found how much KClO3 weighs down here. It's 122.55. So 122.55 equal sign. So we got 4.53 times 2 times 122.55 divided by 2 equals, let's see, hold on. Equals 555.1515. But since I only want 3 significant figures, my final answer is going to be 5 grams of KClO3. Okay? That's the gimmick of mass to mole, or mole to mass, of the two-step variety. Okay?